Hello grade 9, we will continue today the thermal properties of matter. We will find out in this chapter what is the difference between solids, liquids and gases in expansion, what is the thermal capacity and how can we determine it, and what is the specific heat capacity and what is the energy required and how can we determine them, and what is the latent heat of fusion and vaporization. What is the difference between solids, liquids and gases in expanding? Solids expand most slowly when they are heated. For example, Pyrex glass and the metal alloy. They have designed to be expand as little as possible. What about liquids and gases? Liquids in general expand faster than solids, and gases expand faster than liquids and solids. Activity 10.2, it is observing expansion for the solid and liquid and gas. First one, this is a steel ring and that is a steel pole. At first, when this pole is cold, it will go or pass through the ring very easy. When it is hot, it will not pass through the ring. The second one, this is the expansion of solids. What about the expansion in liquids? This is a flask to contain water, okay, filled with water, and then fitted with a bung and a tube. When this flask is placed in a hot water bath, the water will rise here up inside the tube because of the expansion of the liquid. What about the third one? This is a flask contain air only and fitted with a bung and a tube. When it is placed in a hot water bath, the bubbles will coming from the end of the tube. This is because of the expansion of the gas, of the air. Thermal capacity. What is the meaning of thermal capacity? If any material heated or its temperature rises, it will expand. This expansion is called thermal capacity. Again, the thermal capacity, it is the expansion of a material when its temperature rises. The thermal capacity of any object is depends on the kind of the material which is made of. For example, if it is metals, its thermal capacity is very low, and if it is non-metals, it will have a high thermal capacity. This figure shows an electrical heater which consists of thermal insulation, front panel, grill, fan, and metal cover and heating elements. And a special brakes that is store the energy which supplied by the electricity which have a high thermal capacity. Specific heat capacity, S specific, heat H capacity, C, s.h.c. What is the meaning of specific heat capacity? It is the amount of energy which required to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. So in order to calculate how much energy which we need to boil this water, we need to know two facts. The first one, the mass of the water, and the second fact, the increases in the temperature. How can we determine the specific heat capacity? By knowing the energy required. How can we obtain the energy required by multiply the mass by the specific heat capacity, which is C, by the increase in temperature, which is the change in temperature delta T. Delta T means here the change in temperature, T2 minus T1, the final temperature minus the initial temperature. By subtract them, T2 minus T1, we will obtain delta T. The unit for the energy required is joule. Let us take this problem. A domestic hot water tank contains 200 kilograms. It is the mass of the water. At 20 degrees Celsius, it is the initial temperature. How much energy must be supplied to heat this water to 70 degrees Celsius? It is the final temperature. If the specific heat capacity of the water is 4,200 joule per kilogram degree Celsius. This is the unit of the specific heat capacity, joule per kilogram degree Celsius. How can we calculate the energy required? By multiply the mass by the specific heat capacity by the change in temperature or the increase in temperature. How can we get the increase in temperature? We have two temperatures here, the initial and the final temperature. We will subtract them. 70 minus 20, it will be 50 degrees Celsius. So by multiply 200, which is the mass, by the 50, which is the change in temperature, by the specific heat, it will be 4,200. It will be the energy required 42 megajoule. Mega means 10 power 6, okay? Or 42 multiplied by 10 power 6 joule. This table shows the specific heat capacities for different materials such as aluminium, iron, steel, copper, brass, zinc, silver, mercury, tungsten, lead, hydrogen, air, nitrogen, and steam. The s.h.c for the water is 4,200 joule per kilogram multiplied by degree Celsius. How can we determine the specific heat capacities? By this relationship, we will divide the energy by mass multiplied by the change in the temperature. Its unit, it will be joule per kilogram degree Celsius. Again, if we compare the s.h.c of water, which is 4,200, and the s.h.c for the other materials, we will see that the s.h.c of water is an unusual substance. It has a very high value of s.h.c compared with the other materials. It takes a lot of energy to heat up, and it will take a long time to cool down. How can we measure the s.h.c for a 1 kilogram aluminum block? First, we will heat it up by using an electrical heater, and we will record its temperature by using a thermometer, okay, at regular interval time. We will put a small amount of oil, fills the gap between the thermometer and the block, and we will cover the block with insulating material to reduce the heat loss. Then we will draw a graph between the temperature against the time. We will see that the temperature rises more slowly and the heat escapes to the surrounding. Latent heat. What is the meaning of latent heat? It is the energy which is needed to melt or boil a material. Its unit, joule multiplied by kilogram minus 1, or joule per kilogram. So we can divide it into two definitions. The first one, it is the specific latent heat of vaporization, which is the energy per kilogram which required to cause the substance to change from liquid to gas at its boiling point. And the second definition, it is the specific latent heat of fusion, which is the energy per kilogram which requires to cause the substance to change from solid to liquid at its melting point. Remember, there is no change here in the temperature during melting and boiling the substance, okay? So we can calculate how much energy which is needed to melt or to boil the substance by this formula. Energy required equal mass multiplied by the specific latent heat, which is energy equal M multiplied by L. Let us take this problem. If we have a cooking pan contains 0.8 kilogram of water at 100 degrees Celsius, how much energy must be supplied to boil all the water so that the pan is dry? If the specific latent heat of the vaporization is 330 kilojoule per kilogram. So we will put the formula of the energy equal mass multiplied by the latent heat, which is 0.8 multiplied by 330, it will be 264 kilojoule. How can we measure the latent heat here? By using this formula, energy supplied divided by mass.